सो हाय गाइस, क्या हाल चाल है भाई? कैसे हो आप लोग? बताओ. आई एम वेरी सॉरी. I got a little late today because my 9:30 class got over a little late. I was busy teaching them and like I didn't time का ध्यान ही नहीं रहा. So I'm very sorry for that. Please tell me how are you guys? कैसे हो आप लोग? How was your Sunday? And welcome to this new topic of inorganic chemistry for 11th standard, that is the boron family. हम लोग P block start कर रहे हैं. We are starting with P block, and P block for 11th standard there are two groups that we have to study, that is group 13 and group 14. Okay, and we'll try to cover it in a very easy way, as we have covered S block, as we have covered hydrogen. So this the first thing that we would discuss today, and the first part of P block that we would be discussing is boron family. And boron की family मतलब boron के अंडर जो elements आते हैं, boron being the head of the family. Okay, so we will try to learn about it right from the basics. Okay, so let's start today's session. So please do remember that we have already covered S block, we have already covered hydrogen, we have already covered hydrogen peroxide, we have already covered water, hardness of water. We have already done this. If you guys want to revise them, please go back to the created playlists. So please do watch the previous videos. Okay, chalo. Good morning guys. Let's start group 13, that is boron family. So सबसे पहले हम ये जानते हैं कि what is P block. P block is that part of the periodic table in which those elements are present who have their valence electrons entering the p orbital. Okay, so these elements are the ones in which the last electron enters the p orbital. The last electron enters the p orbital. So if you take these elements will have a configuration. So all elements of P block will have a configuration between ns2 np1 to ns2 np6. इसके बीच में ही configuration है. The general configuration will have last electron entering the p orbital, so it can be np1 configuration or np6 configuration. So it can be between this. Okay, now the maximum number of how many p subshell, there's a p subshell. P subshell contains how many orbitals? So it contains 3 orbitals, and 3 orbitals can accommodate a maximum of 6 electrons, and therefore there are 6 different type of elements or 6 groups that exist in P block. So within P block there are 6 groups because of the number of electrons that can be put in p orbital. Okay, because of the number of electrons that can be put in p orbital. For example, d block ले लेते हैं. In d block how many groups are there? D orbital or d subshell has 5 orbitals. Each orbital can accommodate a maximum of 2 electrons. So d subshell can have a maximum of 10 electrons. So how many groups will be there in D block? There will be a total of 10 groups. Similarly, S block only one. The S subshell has only 1 orbital, and the maximum number of electrons that can be accommodated in that is 2. And so because of that, we have only 2 groups. So S block में आपके 2 groups हो जाते हैं, and D block में you have 10, P block you have 6, total of 18 groups in the periodic table. Okay, total of 18 groups of the periodic table. Clear? Chalo, let's discuss. So this is what the P block looks like. So 13 to group number 18, group number 13 to group number 18. Our objective is to cover group 13 and 14. So group 13 and 14 is there in 11th standard and group 15 to 18 is in 12th standard. So this part is in 11th standard and this part is in 12th standard. Our job is to cover group 13 and 14, not 15, 16, 17, 18. 15, 16, 17, 18 will cover in 12th standard. Okay? Clear? Now you can see that there are this bifurcation has been made into, you can see that different color coding is there. So there is a color coding for metalloids. So in metalloids have properties intermediate of metals and non-metals. In group 13, the only element which has dual properties is boron. The moment we come to carbon family, that is group 14, we have silicon and germanium, then arsenic and antimony, then tellurium and polonium. They behave as metalloids. Okay, they behave as metalloids. On the either side of them in this group, we have non-metals. Clear? On the either side of them, we have non-metals. So on either, some are non-metals, some are metals. You can see that there's some non-metals, there's some metals. So these are fairly non-metallic. 17, 18, they are completely non-metallic, and indium, thallium, they are metals. So boron family includes boron, aluminium, gallium, indium, thallium. Boron, aluminium, gallium, indium, thallium. The general configuration of these elements is Ns2 Np1. So देख लो, 2s to 2p1, 3s to 3p1, 4s to 4p1, 5s to 5p1, 6s to 6p1. Okay, 6s to 6p1. So there are a total of 3 electrons that you can have in the valence shell. अगर आपसे किसी ने पूछा कि भाई boron family के elements में number of electrons which are present in the valence shell, then for any element of p block, the number of valence electrons is the number of electrons in Ns plus Np. So Ns, Np, Ns, Np. N represents the principal quantum number. So, or the shell number, you can say that. So boron, 3 electrons in the valence shell, aluminium 3 electrons in the valence shell. The configuration is 3s to 3p1. Okay? Chalo. Let's move on to the next information. What is the trend in the atomic radius? Now what we would expect, the expectation, so please do remember that please do remember one important feature, that these exceptions that we are studying are actually features. Okay, so if I am teaching a class of, let's say, 100 students, it's not necessary that everybody will choose to be an engineer or a doctor. Some people can choose to be designers, some people can choose to be lawyers, some people can choose to be chartered accountants, could be a number of things. I cannot say that they have their exceptions of that class. They are choosing that path which they like. So they are choosing whatever their behavior, their primary behavior is. So we have to analyze each and every information, and many a times these informations look like they are following a linearity, but there are cases where these informations do not follow a linearity. For example, let's start with the first one, that is atomic radius. Expectation क्या होता है? Down the group atomic radius will increase. Okay, down the group atomic radius will increase. So I should have observed that from boron to boron, gallium, boron, aluminium, gallium, indium, thallium. So boron, aluminium, gallium, indium, thallium. I should have observed a uniform increase. But what we are observing? What we are observing is that there is a decrease in the size of gallium. There's a decrease in the size of gallium. Now, इसका reason क्या है? The decrease in the size of gallium is because of the reason that before gallium, before gallium we have zinc. Okay, so before gallium we have zinc. So as d orbitals are larger in size and compared to s and p orbitals, their electrons do not shield the nucleus very effectively. So nucleus exerts a kind of a force which is known as a nuclear charge. If the d orbitals would have shielded the nuclear charge, then gallium would have followed the trend. But the d orbital electrons are not able to shield the nuclear charge, so the gallium gets pulled inside. So if gallium is pulled inside, gallium becomes smaller than what we expect it to be. Okay, hence gallium, the force of attraction between the valence shell electrons in the nucleus is larger, and because of that gallium becomes slightly smaller. The moment d orbitals or f orbitals come into picture, the size of the atom becomes smaller than expected, because the d orbital or the f orbital are incapable of shielding the nuclear charge. अगर shield नहीं करेंगे तो atom becomes smaller. ठीक है? Clear? Please tell me a yes if you have understood this. Please tell me a yes in the comment section if you have understood this, that why gallium is becoming smaller, because gallium के पहले there comes zinc, and zinc has d orbitals. D orbitals contain certain electrons. These electrons will improperly shield the nuclear charge. I've just explained this, just that d orbital will, so these electrons cause something known as shielding, but they will cause shielding properly if they are present in a smaller orbital like s or p orbital. But if they are present in a d orbital, which is very diffused, they are incapable of performing shielding. Okay, so that's the reason gallium becomes smaller. Let's go further. Order of ionization energy. What we would expect to be the order of ionization energy? Ideally, the ionization energy should decrease down the group. So ionization energy order which is given, but the expected order is boron should be maximum, aluminium, gallium, indium, thallium. Okay, boron should be maximum, and so these things should be minimum. However, thallium is not present in its original position. This thallium comes over here, and so the actual trend is boron, thallium, gallium, and aluminium goes over here. Aluminium, indium. Why such? Okay, why such change? Let's try and understand this. So think logically. Let's pick boron, aluminium, gallium. Okay, first and foremost, let's pick boron, aluminium, gallium. If I compare aluminium and gallium, I will observe that gallium is becoming smaller. ये देखो यहाँ पे gallium is becoming smaller than aluminium. So if gallium is becoming smaller than aluminium, then removing electron from gallium becomes difficult. Okay, removing electron from gallium becomes difficult, and so gallium will have higher ionization energy than aluminium. So between gallium and aluminium, gallium will have higher ionization energy. Now, if I go from gallium to indium, the shielding effect increases, and due to the presence of additional 4d electrons, and because shielding increases, atoms become much smaller. So it becomes difficult to remove electron from thallium. So increase in atomic size and screening effect, which overcome the effect of increase in nuclear charge. So the if I go from gallium to indium, I will expect that the ionization energy should increase, but it doesn't, because the increase in size over, or you can say dominates over the effect of increased nuclear charge. Okay. However, the moment we go to thallium, it becomes much more difficult to remove electrons. So gallium indium thallium, there is inclusion of fully filled d or f orbital, and so it becomes very difficult to remove electron from thallium, and so thallium becomes even more than gallium. Okay, क्योंकि वहां पे और कम shielding हो रही है. Okay, so there is even weaker shielding in thallium. Thallium for removing electron from thallium. So the last electron is perceiving a lot of nuclear charge, and so removing that electron becomes difficult, and so thallium becomes more than gallium, and gallium becomes more than aluminium, and aluminium becomes more than indium. Okay. So if you look over here, so it goes like this. Can you see the trend? It decreases and then it increases. It decreases, and then it increases. You can see that there's a slight increase over here. You can say the trend is like this. Okay. If I draw it more properly, it will be like this. Something like this, a W. Okay, a W, kind of a W. So this is the trend that we observe. So boron is 801 kilojoule per mole, thallium is 589. So you can see that there is a very, very small difference. 2 kilojoule का बस difference है aluminium and gallium में, and that's because of an increase in the nuclear charge. Because of poor shielding, thallium is even higher. Okay, chalo, let's go on to the next part, electronegativity. Now, what do you think will be the order of electronegativity? The order of electronegativity should be decreasing down the group. In fact, decreases, but from aluminium to thallium, it increases. Why does it increase from aluminium to thallium? Due to the poor shielding of D and F subshell, the F nuclear charge is increasing, and so the tendency to hold the electron, or the tendency to attract the electron pair from a covalent bond, increases slightly. So there is a slight increase. It's like a V. Okay, so down the group, electronegativity first decreases from boron to aluminium and then increases. So please do remember the shapes of these graphs. It will be easier for you to remember the trends. Okay, is that clear? So slight increase is observed from moving from aluminium to thallium, because the D orbital and the F orbital are not capable of shielding the nuclear charge properly. So the last electron is perceiving a increased nuclear attraction, or you can say that this increased nuclear charge, or this non-diminished nuclear charge, can pull the electrons from a covalent bond to a greater extent. Okay, so chalo, let's move ahead. Let's take this question. Aluminium and gallium have the same covalent radii, almost the same covalent radii, because, okay, Yogin Parmar, is this for 2021? When 2021 will have so many topics. Okay, 2021 will have, if you're appearing for 2021, obviously this will become important. Okay, JEE does not include portions only from 11th standard, it also includes portion from 12th standard. So the right answer to this question will be aluminium and gallium have the same covalent radii, because what should be the right answer? Poor shielding of D electrons of gallium. The right answer should be C. The right answer should be C. Okay, next. The ionization enthalpy of the elements of group 13, remember that W. Okay, remember that W. Decrease, increase, decrease, and then increase. So ionization enthalpy for elements of group 13, the right answer should be boron. What do you think will be the right answer? What would be the right answer? The right answer will be D. The right answer will be D. No, no, no. It will not decrease uniformly. I have just told you that boron and then thallium and then gallium and then aluminium and then indium. A is incorrect. Ionization enthalpy of group 13. No, it does not follow that trend. Absolutely not, Ganesh. It does not follow the trend. Please watch the video once again to understand this. There's a change in the trend. Okay, ये S ब्लॉक के जैसा यूनिफॉर्मली डिक्रीज नहीं करता है, गैलियम पे इंक्रीज कर जाएगा, फिर थैलियम पे भी इंक्रीज कर जाएगा. Okay. Now next is inert pair effect. Now what is inert pair effect? Inert pair effect is actually the observation. It's not the reason. Inert pair effect is the observation that the lower members of the group 13 in P block, the lower members of the group tend to show a lower oxidation state, or they have a more stable lower oxidation state. इसका मतलब ये होता है कि if I take boron, aluminium, gallium, indium, thallium, the general oxidation state will be +3 because there are 3 valence electrons. So general oxidation state will be +3 because there is a ns2np1 configuration. You can remove all 3 electrons, but as you go down the group, the more stable configuration becomes +1. This is a stable more stable oxidation state becomes +1. Stable configuration will be ns2. Okay, so each element is capable of showing +3 and +1 oxidation state. However, for boron, +3 is stable, but going down the group, +1 becomes stable. That is known as inert pair effect. This observation is known as inert pair effect. Now what is the reason for this inert pair effect? बोलते हम ये हैं कि this ns2 electrons do not tend to go unpairing and they do not undergo ionization. Okay, so increased nuclear charge holds these ns electrons tightly and restricts their participation in bonding or ionization. However, what's the different reason भी है हमारे पास? Remember that any ion which is stable or not will depend on the fact that whether it forms a stable lattice or not. These ions, if are produced, they will form a lattice by combining with an anion. Now lattice जब बनता है तो lattice energy बाहर निकलती है. Okay, lattice, whenever a lattice is being formed, lattice energy is given out. So that is like the outcome, that is like the returns. What is the investment? The investment is ionization energy. First you have to ionize a metal and then you will get lattice energy. Now what kind of business venture anybody wants to do? Anybody wants to do a business venture where they would have less investment and more returns. है कि नहीं? You would want to go into a college where you have less fees, but the outcomes, the career opportunities that you can get after passing out from the college will be more. The return on investment, ROI, will be more. So the investment in these metals while they are forming compounds is ionization energy. This investment is very high. Okay, going down the group, the investment increases. The lattice energy, however, does not become that very large because the size is also large. Lattice energy decreases with increase in size, so the return on the investment is decreasing. Okay, return on the investment is decreasing. So for thallium, it is more in, if I take thallium plus 3 and form compound with chloride to form TlCl3, and I form Tl plus 1 and form compound with chloride to form TlCl. In this formation of this compound, the lattice energy dominates over ionization energy, and in this case lattice energy is less than ionization energy. So please do remember that the amount of energy which is being given out has to be more than the amount of energy that you're investing in, and if it is not happening, then a lower oxidation state will be preferred. So in plus 3 oxidation state, this is the scenario. In plus 1 oxidation state, this is the scenario. That is the reason the plus 1 oxidation state becomes more and more stable going down the group. Okay, ये कलर्स नहीं शो करते हैं. कलर्स जो शो करते हैं वो डी ब्लॉक के एलिमेंट्स होते हैं और डी ब्लॉक के मेटल्स होते हैं. Okay, so if you look at boron's plus 3 oxidation state is most stable. It is a non-metal. Aluminium and gallium, they behave as metalloid, and the plus 3 oxidation state, stability of the plus 3 oxidation state decreases. Plus 1 thallium plus 1 oxidation state dominates due to inert pair effect. Okay, so P block. So हर ग्रुप में ये ऐसा रहेगा. For example, carbon group. Carbon is present in group 14. The general oxidation state has to be plus 4. So carbon can form plus 4 compounds in plus 4 oxidation state, but going down the group, the last element is lead. Lead plus 4 oxidation state is less stable, plus 2 oxidation state is more stable. Clear? Chalo. So let's take this question. Stable compounds in plus 1 oxidation state are formed by. Stable compounds in plus 1 oxidation state are formed by. What is the right answer to this question? Bataiye, what is the right answer to this question? The right answer to this question would be D. Thallium. Thallium will form stable compounds in plus 1 oxidation state because thallium's plus 1 oxidation state is more stable than plus 3 oxidation state. So it is thallium among these whose plus 1 oxidation state compounds are more stable than plus 3 oxidation state compounds. Next, which does not exist? Very beautiful question. Which does not exist? Among B3 plus Al3 plus Ga3 plus In3 plus, the existence of B3 plus will be highest because the highest oxidation state, that is plus 3 oxidation state, can be achieved by the first member of the group. Going down, the tendency to show higher oxidation state decreases, the lower oxidation state increases. So the tendency for In3 plus to exist will decrease. So the right answer will be D. The right answer will be D. That among these, the least stable one with plus 3 oxidation state, the least stable element with plus 3 oxidation state will be In3 plus. Okay. Now let's analyze the physical properties. The physical properties are very, very simple to understand. So boron is non-metallic, extremely hard. Boron के कुछ सारे compounds जो होते हैं, they are used as abrasives. Abrasive means they are very very hard. Boron is very stable. The boron has high melting point and high boiling point. In fact, it has the highest melting point and highest boiling point because of a very, very stable, very, very strong lattice. Okay, lower members have lower melting point and lower boiling points, and they have higher electrical conductivity. Boron is non-metal, but as we go down the group, the metallic character increases, so the conductivity or the tendency to transport charge also increases. Gallium is pretty interesting. Gallium is used in high temperature thermometry. High temperature thermometry. Why it is used in high temperature thermometry? Because you can see that its melting point is 303. 303 का मतलब 30 डिग्री सेल्सियस पे मेल्ट कर जा रहा है. Okay, so it is used in high temperature thermometry because at 30 degrees Celsius it is in the form of a liquid. It has turned into a form of a liquid, and it will be a liquid until 2676 Kelvin. Okay, so 2676 Kelvin means somewhere about कितने हो जाएंगे? So 273 if I so 2403 degrees Celsius. So from 30 degrees Celsius until 2400 degrees Celsius it is existing in the form of a liquid. So high temperature thermometry, if I have to measure something at the which has a temperature of 1000 degrees Celsius or 2000 degrees Celsius, I do not want the substance which is present inside the thermometer to boil off. Mercury लेंगे तो boil off हो जाएगा, but if I take gallium it will not boil off until 2400 degrees Celsius, so I can use it in high temperature thermometry. Okay, so please do remember this is the property of gallium. It turns into a liquid not at room temperature. Room temperature is 25 degrees Celsius, slightly higher than room temperature. 30 degrees Celsius पे melt कर जाएगा. If you keep it in your hand it will melt. Okay, and density increases down the group. Why does the density increase down the group? Because the what is density? Mass per unit volume. So volume is increasing, mass is also increasing. Density increases because the increase in mass dominates over increase in volume. So mass increase is more than volume increase. Okay, mass increase is more than volume increase, and because of that the density increases down the group. Okay, chalo. So let's take this question. Which member of group 13 is liquid at 30 degrees Celsius? Okay, बहुत simple सा topic है. Actually, I don't know why do you guys panic about group 13. It's a very simple topic. There are few compounds that you have to study, and only from these compounds questions are asked. So when we will go and study chemical properties, we'll find that these chemical properties are only limited to some elements. We do not study all elements. We do not study the properties of all elements because it's not needed, it's not required. Okay, so we study the chemical properties of only some elements, mostly boron and some of its compound like chlorides, hydrides, oxides. Okay, that's it. Aluminium के भी oxides हम पढ़ते हैं, बाकी और नहीं पढ़ना है हमें. All reactions do not need to be memorized. Some reactions have a particular linearity. Okay, the right answer is which member of group 13 is liquid at room 30 degrees Celsius? The right answer is gallium. Okay, the right answer is gallium. And the last question for the day is this. On moving down group 13, the density will क्या होना चाहिए? What should happen to the density? I just explained it to you that mass is increasing, volume is increasing, but the increase in mass dominates over the increase in volume. So the density has to क्या होना चाहिए? Increase. The density has to increase. Okay. So with this we finished the first lecture of group 13. Very simple, very short and sweet lecture. Please do remember all these points, make short notes, and In the next class, we will start with chemical properties. So I believe by the end of this week, we should be able to finish group 13. Okay, we should be able to finish group 13. Next week, we will be doing group 14. So I'm hopeful of finishing the P block entirely before November so that your inorganic chemistry will be taken care of. Okay? And then after we will take a lot of like one shot classes and we'll take a lot of revision classes, but your 11th standard inorganic chemistry will get over by the end of November. Okay? So with this, I Saurav Goswami take leave and we'll meet each other on Wednesday again at 10:30. Remember, 10:30 is the timing for 11th standard classes, 9:30 is the timing for 12th standard classes. Okay? So I hope you have learned about group 13 a bit. Very simple topic, very easy topic, and we will continue from here in the next class. In the next class, we'll start with chemical properties. We'll first learn the general chemical properties and then we'll take properties of some individual compounds. Okay? Chalo. So let's meet on Wednesday. Until then, bye bye. Take care. Have a lovely day.